step number 1 under the obtain the regression model, how we get estimated regression sample model. So first, you're going to remember how this estimated regression sample model look like. Y hat equal to B0 plus B1x. So this is the equation you have to remember. Y hat equal to B0 plus B1x. B0 plus B1x. And then the method we're using to estimate this method, this model, B0 and B1, is called least square method. So least square method. And so what we are doing here, I want to show you what is the least square method. So y is the real observation, and yi hat is the estimated observation. So the real observation, the differences between the real observation and the estimated observation, and then you square it and sum all those differences, square the differences together, and you try to find which value is going to give you the smallest differences. So basically, you try to make sure your prediction and the real value are very close to each other. So this method is called the least square method. And so you have to remember this expression because your quiz, you're going to use this your quiz due this weekend has gonna relate to the least square criterion. So least square criterion. So yi is the real observation. Yi hat is the estimate observation using your sample model. So your goal is try to find the outcome of B0, B1 that can minimize the differences between the real observation and estimated observation. So that makes sense, right? And so we're gonna look at the example first, and then you should switch to the computer skill. And so after you estimate the value for B0 and B1, I always gonna ask you to interpret the slope. And so after you receive the value for slope, this is the interpretation formula to guide you to write down your interpretation. If x increased by 1 unit, if let's say the value of the slope equal to B1, so how you gonna interpret B1? So B1 means if x increased by 1 unit and y will increase by B1 unit. So you're always starting from x variable. So x variable is, remember, it's called independent variable. So they are not dependent on any y variable. So they can move first. So that's why we are assuming they move by 1 unit. So in order to respond to this 1 unit move of x, y actually will move by B1 unit. However, if the B1 is a negative value, you should change the increase to negative decrease. So let's look at this example. Let's say B1 equal to 2. So if that means if you want to interpret this 2, so that means if x increased by 1 unit and y will increase by 2 units. And so if the B1 equal to negative 2, that means if x increased by 1 unit and y will decrease by 2 units. So that is how you are using this interpretation formula to help you to interpret the result. So obviously we talk about theory. So now we're going to look at how we're going to use the theory we learn to real world problems. So let's see, for a sample of 8 employees, a personnel director has collected the following data on the ownership of a company stock Y versus a year with the firm. So you can see there was 2 variables in this case. So which one is my x variable? The year with the firm. Which one is my y variable? So that is ownership, the number of the ownership, how many stock that employee owns. So basically, for this study, they try to predict the number of the stock the employee own given the employee's working experience with these firms. So now we collect 8 employees. So you can see the value will be 6, 12, 14, 6, 9, 13, 59. And the y variable, so for the employee who worked for the firm for 6 years, the share is 300. The employee worked for the firm for 12 years, the share he owns is 408. So you can read the data pretty smoothly. So now, the reason they collect this data is they try to use the year working for the firm to predict the number of the share they own. So that's why the question number 1, determine the least square regression line. So the reason we don't call it here, we call the least square regression line is because we're using the least square method to estimate the simple linear regression equation. So you have to put a note for yourself. Although we call it least square regression line, actually we are asking for the estimated regression equation. So estimate the regression equation. And then after you got the equation, you have to interpret its slope. So how can we answer this question? So first, you're going to look at your chapter 14 handout. I asked you to print it out or download ahead. So make sure you should find that handout first. So chapter 14 handout. So this is the handout you need to use. As I said, make sure you download it because you're going to take a good note. So every time the Excel will give you the similar Excel output, the number one job for you is try to find the right number to answer the question. So let's look at this first table you see. So every time you run the regression model, so after we look at this example, and I will give you time to watch the computer skill 4, and in that video you will be able to learn how to generate the 3 tables. So on this table, on this slide, you will see 3 tables. So basically, it's on your first handout, and so you see 3 tables. Pay attention on the third table. So when you look at the third table, and you will see there is one row called intercept, and one row called x, and one column called the coefficient. And so if you think about the estimated simple linear regression model, what we try to estimate is the B0 and the B1. So where is the B0? So I hope you can use your handout to label it. So the intercept, remember B0 is called the y-intercept. And so that is where you find your B0. So the B0 equal to 44.3140. And so the one under B0, that is where you'll find the value for your slope, B1, 38.7558. So you'll find B0 and the B1. So basically, you'll find the 2 parameter you try to estimate. So you write down those numbers and put them together. So here is the answer for the first part of question number A. So what is the estimated simple linear regression equation? Y hat equal to 44.3140 plus 38.7558x. So this is your B0 and B1. So remember where to find B0 and B1. No matter what kind of data you're dealing with, if you use Excel to generate this output, it's always the same location. That's why I asked you to print it out and then to label it, because you might need to use this handout to guide you to work on your homework, and because you have to remember where is the location for B0 and B1. So after you receive the value for these two, B0, B1, so this is your final answer for the first part. And so determine the least square regression line. So that is the answer. So now look at the second part. Interpret the slope. So the slope value is equal to 38.7558. So how are you going to interpret this result? So let's go back to look at the interpretation formula. So this is back to a few slides. So the slope B1, if x increased by 1 unit, y will increase by B1 unit. So basically, we have to figure out who is my x variable, which is my y variable, and then replace B1 by the B1's value you find from Excel output. So the x variable is the year work for the firm, and the y variable is how many shares they are owning. So the B1 is 38.775. So that means if the employee work 1 more year, so if employee's working experience increased by 1 year, and the number of the share owned by that employee will increase by 38.7558 shares. So that is how you interpret the slope. So let's look at the answer. So interpretation, for every additional year an employee work for the firm, the employee acquire an estimate 38.8 shares of stock per year.